Everybody, welcome to Geology. Let's talk human effects on flooding. So I threw up two things. One, how urbanization affects the water cycle. This is put out by this group right here, and it does a great job, especially the first two pages of summarizing a big chunk of what I want to talk about here. And I threw up kind of a crappier version, one that I made, with a couple graphics from the book. All right, so let's jump in with going to Google Earth. So this area, this is Central Square in 1995. Before I was teaching, I worked in construction material testing or construction, like testing the grounds before they built something to make sure it was compact enough, essentially, to put something on top of it, like a Walmart. So this area right here would eventually be the Central Square Walmart, right? And if I pop forward, there it is. All right, so it was probably about 2000, 2001 or so that this thing was built. And it's kind of a classic, not a classic, it's just a Central Square Walmart, kind of a typical kind of story on how changing the landscape can lead to flooding. So they did a couple of things. First off, this was a hill slope. From the highway here, going down, 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 that was a gentle hill slope. Second, it had some vegetation on it. Yeah, some farmers' fields, but some woods through here as well. I guess those are the big two. Well, so what happened is before the store was here, right? This was early in construction when there would have been just this would all still just been compacted soil material. There was a floor slab and maybe some framing, but no store necessarily yet. Anyway, we got to the site and it was completely underwater one day. So why? Well, first off, to build a Walmart, you have to have it on a flat area, right? So they took what was a hill slope, a gentle one though, that went from here and gently down, and they oversteepened it. So over on this bank was really steep. Now, if you go there, you can see this, that if you go over to this side of the parking lot, there's a pretty steep hill over on this side. Second, you change the cover. You go from having vegetation to no vegetation. Vegetation helps water infiltrate into the soil. The plant roots help keep the soil aerated, whereas when you strip that, that's gone. So before any storm sewer system was put in, that whole entire site flooded thanks to a reasonably heavy rainstorm the night before. And we all got to go home, right? But they did manage to work their way out of this. Now, they did manage to work their way out of this. You do engineer your way out of this, right? By putting in storm systems to divert the water away from the site, because obviously you can't have a Walmart that's underwater every time it rains. And I'm sure, yeah, today it looks pretty much the same. So the storm sewer systems being one, and then this idea down here that there are now retention ponds down here. All right. So it's an addition of impervious cover is what it's called, and I think this thing does a pretty good job defining that, which is right in your segment 5 thing. Impervious cover, that surfaces that do not allow water to penetrate the soil. So if you were a raindrop back in the day, and I think I said this back in the first video, if you were a raindrop back in the day heading down towards this area, what would it have been? Like all woods, right? Even let's go back before there was even Route 81. Now that this is paved over, or rooftops, things that do not allow any infiltration whatsoever, that same amount of water essentially still hits the ground in the same like type of storm. So that water now has to go somewhere that the ground is not necessarily, I don't want to say designed because it's not designed, but the ground hasn't necessarily evolved towards. The shape of the land hasn't necessarily evolved towards. I think I did this on the first day with the area around Great Northern Mall, which should be right about here. So in the end, that first video, I probably did this trick, right? Where if you go back to this when I was in high school, there really wasn't much there. And then again, get rid of that. And you've got to deal with how much water there is now going to be not soaking into the ground because of all of this impervious cover. And again, we have retention ponds all over because of that. So that is small scale what we're talking about here with how urbanization affects it. So those are two like small scale, small retail properties in the middle of upstate New York with a lot of land around them, right? But do this to a continually developing city, and the problems get larger and larger and larger, right? So they do a great job. I mean, this infographic's perfect. It summarizes everything. So please check it out. Of considering that difference between developed lands and natural lands. So if we want to think about that on a bigger scale, Syracuse is a pretty good example of that. If we were to go and just consider Syracuse, right? So first, let's remember our drainage basins. Water's coming up from as far south as Tully, right? So that whole Onondaga Creek comes from Tully up through that valley that Route 81 resides in, and works its way north into Onondaga Lake, and then it heads out up towards the Oswego River. Now, the amount of pavement that is here that would not have been here hundreds of years ago um, means that things are going to be a lot different when the water hits the ground, right? Now, so I mean, just it's looking at it in satellite view just gives you a kind of perspective on how much of this is no longer land where water can infiltrate, and it's turned into a problem in Syracuse. Along the south side, there's been flood zone changes because of really stormwater runoff. How much that this creek, Onondaga Creek, which if I'm looking at it right here, I'm more familiar with it up here. How much that creek can get water north and bring it out of town versus how quickly that water is going to flow into it. And now again, if we could go back hundreds of years before there's Syracuse, what would the shape of this thing have been like? How quickly would water have infiltrated down through the soils or run off across the surface to get into that? And then how did that balance over the course of like everything since the glaciers like create the shape of Syracuse as it is, right? And this has turned into a problem. And Syracuse actually has a pretty good, they're attempting to deal with it with a pretty good program called Save the Rain, if you've ever heard of that. This is my old neighborhood when I lived over here. When I did live here, they would give out rain barrels for free with the goal of if you have downspouts on your house, right? So that was my house. If you have downspouts on there, instead of having that water go right down onto the streets and into the storm sewer systems, which then goes right downtown, how about we try to keep 55 gallons of it, which might not sound like much, but if you do 55 gallons multiplied times the number of these things that they could get out in the community, it was a lot of water. How could we keep that out of the system? This is compounded by a bad idea in Syracuse, which was, and they're not the only city by any stretch, which was a combined like septic and storm sewer runoff system. So both toilets and street sewers would go into the same system. They'd get down here to this processing facility on the south end of the lake by the Carousel or Destiny Mall, and with a heavy rainstorm, with that much very rapid runoff, it would inundate this facility, and they would have no choice but to open the floodgates and drop raw sewage right into Onondaga Lake, which is terrible. It's an already extremely polluted lake. We don't need to make it worse. So let's look at the note sheet there, because this one, and this is out of your book, this is what that would look like graphically. And it's not totally dissimilar if you paid attention to the whole flatten the curve idea during COVID. It's not a totally dissimilar philosophy to that. That if we manage to just slow things down, the peak does not get as bad, right? So if you have a heavy rain system and it's a natural area, there's a larger lag, which is a time, it's a gap in time between when the rain event happens and when the peak flow will be in the stream system. Whereas if you pave everything over and then you construct pipelines to deliberately bring it to the stream as fast as possible, you decrease that lag time. And on one hand, it feels like a good idea, like, hey, get the water out into the stream and out, gone, out of Syracuse, right? On the other hand, that's a lot of water, right? So if the system is not designed to meet that, then trouble ensues, right? Another thing they've done is they've built rain gardens, and there's good examples of this. This one you can see, and for a while you could still see. So they build it up a bit, then they dig a deep depression, and they fill it with vegetation that can handle flooding and ebbing and flowing, right, over and over again. And in fact, for a while you could see maybe I'm wasting time here. You could see the cut. Yeah, there you go. You could see like right here, this is when they first constructed it. So they took storm sewer systems, unplumbed them from heading downtown, and just ran it across the street into these rain gardens. There's one here, there's one underneath the trees here, and then there's a few. If you go to the zoo at all, there's a really nice, they'll explain all this, and there's a really nice info display in a couple of them right here. And there's a few more down at the bottom of the hill by the zoo right there. And they're just meant kind of like a retention pond, but like in the community more than just off of one facility. Kind of meant to do the same thing though. If you can reintroduce a lag by having some of the water flow into this and then slowly seep into the ground, and you can have the where are we at? This right here, you can have one where okay, it can fill, but then you can hook up like a weeping pipe that will then take. Okay, we're only going to let it get so high before then we're going to take it and get it out through the storm sewer system. So you can do a bit of both with that. But that reintroducing that lag will slow down the amount of water that's going to rush down to the creek. Sorry. And take pressure off that system. Right? So that's what we're going to continue to think about with this. Like, what, think of Syracuse, think of that Walmart in Central Square, but think of like Syracuse kind of in the same philosophy that all these individual pieces of rooftop and asphalt and concrete kind of behave the same. Right? And you can compare that to other, let's turn off this, you can compare that to other like more natural creeks. I know one of you talked about flooding in Camillus. I'm not saying there's no flooding here, but if you go, let's find Camillus. Am I getting lost? Yeah, if you take this road between Marcellus and Camillus, you go through 9 Mile Creek. Here we go. If you look at some of this, so see this here, you got your floodplain is still kind of intact. You got this meandering stream. It's a much more naturalized area. They're similar in terms of like their Onondaga Creek is probably a bigger drainage basin upstream, but they're roughly similar without the nature of there being an entire big city on this, right? So what's different is that you've got all the vegetation still intact and you've got the floodplain that's larger. So how would those two be different in terms of how they react to a similar storm? Is a question that I've put on this quiz in the past. This one being severely channelized and again then having all of the water pumped straight into it is going to be a different story than what will be there. You can take the if you get a chance, go to Syracuse from the Armory right here where the most is in Armory Square. You can do this creek walk. You can walk along this and see it. It does a jogs around West Tennessee Street right here, but you can get back along it and see. And it's like, I'm not saying it's not a pleasant walk. It's very nice, but it's a different situation when you've got like a channelized creek with concrete or stone sides that's deliberately built to rush the water out as fast as possible compared to what we just saw over there at 9 Mile Creek. All right. All right. This little diagram just kind of shows that same idea that if you just have direct to the stream, it's going to be more flashy, like we talked about with the upstream floods. Reintroducing those either retention ponds or rain gardens can slow that down. All right, jump topics a little bit. Let's go to and with all of that, again, I don't know if there's anything else I want to check out on this, but check this out. The first 2 pages on this are right in the money. And I actually noticed this today. If anybody had the Ellicott City floods, we talked about that in one of my earlier videos. Ellicott City is very prone to this because of the nature of where it's built on steep hills in the Little Canyon, but also all of the upstream development in the last couple of decades, with that area getting more and more populated, has led to more and more flooding there. All right, jump topics. Let's talk levees. Hopefully this looks kind of familiar to us now, right? We got a floodplain, we have a meandering stream. Let's consider this like in the Mississippi system. What we've done in many places is build levees, just big long mounds of either earthen materials, some concrete, some reinforcement in places to try to keep that within a certain amount of real estate, right? And leave the stuff outside intact, which seems like a great idea, right? Here's the problem, and this diagram kind of alludes to it as well. let's look at this in profile. If I were to really like just cut this in half and look at it right from the side, what we've got is the floodplain. Excuse my drawing. And a river channel, which shouldn't be right on top, but we'll deal with it. So let's say through time, floods goes back in the channel, floods goes back in the channel over and over again. Maybe this thing's over here, maybe it's over here, whatever, right? It does its thing. It creates this floodplain. It gives us all this great fertile land. Now the humans show up and we say, let's decrease how much that flooding is so that we can do X, Y, and Z to this land. So we go ahead and we build levees. Well, here's the problem. Every time that it floods, it would spread its sediment across this whole entire floodplain, right? Which, again, is why it's fertile. Now when that happens, it's still going to spread its sediments, but now it's constricted. That's not happening over here, question mark, or over here. So you might build up, you might keep a stream channel here, but you might build the land actually higher, increase the gradient of the stream inside those levees. And if it floods again, you build it even higher, and you build it even higher, and you build it even higher. And if you can play that tape forward a little bit in your head, you're going to see that the land inside the levees can get higher than the land outside the levees. And if you can play that tape forward a little bit, you can probably guess what's going to happen when there is another flood. That decreases significantly the effectiveness of these things, because the flooding now is going to be worse than it would have been before to this area, being that it's lower. Coupled with that is the idea that we have, through agriculture, irresponsible agriculture practices, and I'm not saying everybody does this, but what one practice is to plant a lot, fertilize the daylights out of it, harvest it all, and then in between that and the next planting, it will just be exposed. And when it's exposed, any rain that falls on it is going to carry away a lot of that sediment. A lot of people have wised up on this, and there's ways to trap sediment, and there's cover crops, and there's things like that to keep your soil on your farm, which is important not only for the overall ecosystem, but really important for your farm. You're a soil farmer. You need that stuff to grow, right? Well, for everybody that didn't do that, now all that sediment, and this was another thing we said early in there, remember, rivers are not just flowing water, they're flowing water and sediments. So consider all of the farmland that we're considering here. Let's back out of Syracuse. And all of the sediment that could be loose on all of those farms. It's an unbelievable amount of material that can get built up. Like, consider this whole floodplain here. If everybody loses even a fraction of an inch of soil, that all washes into the river. You're talking an enormous, enormous, enormous amount of sediments. So even if we don't do this like levee game here, the buildup of sediments, because we've set so much loose from the land inside the river channel itself, kind of leads to this same exact idea and the same exact problem, that the gradient will get higher and higher and higher, and the water level will get higher and higher and higher. And then when the flooding happens, it is that much worse. All right, that should hopefully, everybody, wrap it up for our flooding section. And hope you're doing well and that you do well on the quiz. And we'll see you for the next one. Take care.